This picture shows you an apartment construction site. So, what is building designing? What are the activities related to that? First, need and purpose. Second, how it will stand. Third, luxuries. So, who are involved in this business? Every project will have a manager who coordinate and combine all other activities. An architect is responsible for the functionality. Structural design is for safety. MEP is actually electrical, plumbing, air conditioning and fire safety services comes under it. Okay, now just consider the structural part of the building. What are the main components? Floor on which we stand is called a slab, which rests on beam, in turn are resting on columns, supported by earth with the help of footings. Staircase is an accessor to the upper floors. So what exactly are we going to learn in this course? I would show you an elevation and plan of a RCC G+2 structure. This is the rear view elevation of that building. This is the front view elevation of the building. And this is the plan of the building. We will create the STAAD model for this building. Let's see the description. A G+2 structure at Bangalore. Why was the location mentioned? Wind and earthquake loads will be calculated depending on location. Okay, we'll see it later. Actually, we practicing structural designers have a good mathematical level. We never cross class with math. So students must come to our level. I hope this doesn't disappoint you. If the building has been shown to you, has been asked to perform analysis manually, we practicing structural designers will never solve the problem. If the question was to you, might take 1 month at the best efforts, but in real, our clients ask us to complete the problem in 2 to 3 days, which lead us to STAAD. We will learn the structural simulation using STAAD.Pro in detail. Let us ask, what is the most important thing for a structural designer? He has to stand on safety and economy. Those are the two legs for him. But how can I say my structure is safe? Who will confirm me? Here comes the government, who has publicized several building codes for general usage. That is, that IS codes and all. If you satisfy them, the structure is safe. But if you are designing a 100-story building, codes doesn't specify anything for that. Prototype must be built and real valid test must be conducted. That is out of our scope. Let's see codes. What does they propose? Loads. Loads are again classified into gravity and lateral. Gravity are quite simple. Lateral, wind and seismic, detailed calculations will be covered. Analysis will be done using STAAD, but STAAD results will not be blindly taken. Manual verification is done. How it is? A detailed discussion will be conducted. Codes do not have much say with analysis. In case of design, they speak a lot. All the variation between British, American and Indian come here. It is actually quality is inversely proportional to factor of safety. What is this? Consider the quality of a steel. If the quality of steel is maintained at high standards, the factor of safety can be taken less. If the quality of steel produced is of very low standards, then the factor of safety will be taken high. The factor of safety all depends upon the code maker's experience. I would like to share a small fact. British standards before 97 were using a factor of safety for steel as 1.05. After 97, the factor of safety for steel has become 1.15. Do you guess what it is? Do you know why? Lucky Metal has been becoming the biggest producer of steel by that time. Just kidding. Okay, it's time for economy matters. I think STAAD not only is a matter of economy as it is faster, but it is a question of survival for practitioners as they don't do your math level. Okay, STAAD takes input in two ways. One by graphical interface and another by editor. Editor is basically a programming language. It is a bit tough, not required to learn, but really helpful in some cases. What are those cases will be discussed in detail. STAAD is actually a matrix displacement based method. You must specify the materials, geometry and properties before analysis. That is, first design some approximations, then analysis, then redesign. STAAD will be covered in detail. We will learn application of wind and seismic weight methods. Also, we will do a small project on steel frame design using STAAD. Best way to read the output from the STAADs will be also discussed. All the designs will be based on SP16. It's a design handbook. Let me make clear. If you are designing a doubly reinforced beam, may take 40 to 50 lines. We do it in 5 lines with our mathematical standard. This course covers those methods. Hope this presentation made clear the topics that will be covered in this course. If any clarification required, please feel free to contact me by this is my mail ID. Thank you.